folk science. Today we have here Claudine stew. They have found the new cure for pain.
Yes, it is morphine.
It comes from
Poppy seed.
Stew and Claude's poppy seed farm, and we will see the morphine in action.
Let's go!
This is Stu and Claude's personal farm of poppy seeds. This is where the morphine is made. The history records say that Frederick, a 20-year-old pharmacist, assistant at the time, discovered, he wondered about the medicinal properties of opium, and in a series of experiments published in 1806, he managed to isolate an organic alkaloid compound and resinous gum secreted from the opium poppy.
He found that opium with the alkaloid removed had no effect on animals, but the alkaloid itself had 10 times the power of processed opium.
Frederick named the substance morphine after Morpheus, the Greek god of dreams, for its tendency to cause sleep.
Now we will show a video to explain this amazing thing these two men have discovered.
Ready?
Now.
The molecular formula of morphine is C17H19NO3. It has a molecular weight of 285.35 grams per mole. Morphine's pH is 8.5 and its pKa is 8.21 at 25 degrees Celsius. The structure can resonate due to the benzene ring and the multiple pi bonds. Morphine is a highly potent opiate alkaloid, a nitrogenous organic compound isolated from a poppy opioid plant, most commonly known as poppy. This is produced synthetically. An alkaloid is defined as any class of naturally occurring organic nitrogenous-containing bases.
In 1874, chemists that were trying to find a less addictive form of morphine made heroin, which actually has twice the potency of morphine. They found that the opium alkaloid can be converted into heroin. It is only 2 functional groups different than morphine. Morphine is commonly treated with acetic anhydride and ignited to yield heroin.
Morphine's effects include euphoria, pain relief, drowsiness, reduced anxiety, false sense of well-being, and relaxation. It's said to be the most powerful pain relieving medicine has to offer. Morphine interacts with the reward center for the brain. The brain responds to morphine by building more components for the G protein signaling system. Over time, more and more morphine is needed to have the same effect on the system. When morphine is removed, the normal function of the pleasure system is dulled by bloated G protein signaling systems, leading to severe withdrawal symptoms. These symptoms are how addiction begins.
As Marcos Narcos said, Frederick Wilhelm Adams Serturner, a 21-year-old pharmacist assistant at the time, had wondered about the medicinal properties of opium. In a series of experiments published in 1806, he managed to isolate an organic alkaloid compound from the resinous gum secreted by the opium poppy. Morphine binds to and activates opiate receptors such as delta, mu, and kappa. It affects the central nervous and gastrointestinal systems with effects such as analgesia, anxiolysis, euphoria, sedation, respiratory depression, and gastrointestinal system smooth muscle contraction. The most dangerous result of consuming morphine is the high potential for addiction. Most other painkillers have an upper limit, meaning that at a certain point, larger doses will not have any more effect on the human body. Morphine, however, does not have an upper limit. This is one factor that makes it such an effective painkiller and also highly addictive.
Marcia D. Gates, Jr., a scholar and teacher at the University of Rochester, was the first person to synthesize morphine. During World War II, many chemists were searching for a way to synthesize it. Gates figured out how to synthesize it and also confirmed the structure of the molecule.
These are the steps Gates took in order to synthesize morphine in a lab.
The first recorded use of morphine was in 1818 when a French physician named Francois Magendie published a paper that described how morphine brought pain relief in sleep to a young girl who had been suffering from pain and unable to sleep. This event caused widespread medical interest among other scientists and doctors across the globe. By the mid-1820s, morphine was widely available in Western Europe in standardized doses from several sources.
Hydrolysis occurs in the body to regenerate morphine.
In 1853, the hypodermic needle was developed and the use of morphine became even more widespread. It was used as a painkiller during the American Civil War. However, many soldiers became addicted to the substance.
In 1839, British sent warships to the coast of China in response to China's attempt to suppress the opium traffic. This began the First Opium War.
Until the mid-18th century, the Chinese, like the British, used opium for medicinal properties. Then they began to use it for recreational purposes.
Morphine, codeine, and thebaine are all found in the opium poppy latex. This latex is harvested by growers who make cuts in the pods before the pods ripen. The latex seeps out of these cuts and is collected as crude opium when it dries. Opium alkaloids are not found in the seeds of the opium poppy, but are transferred onto the seed coats through this latex during the harvesting process. Milky fluid that seeps from cuts in the unripe poppy seed pod has, since ancient times, been scraped off and air-dried to produce what is now known as opium.
Morphine reacts directly with the pain-modulating receptors in the nervous system, called opioid receptors. These receptors respond to natural compounds, such as enkephalin, built by our bodies. These compounds control the levels of pain experienced under different circumstances. Endorphins, our own version, most commonly known by being released during exercise, also reduce pain levels. Morphine mimics the effect of endorphins in the body. They bind to receptors, and the pain-killing message is transmitted through the body through a G-protein cascade. G-protein cascades are a family of proteins that act as molecular switches inside the body and are involved in transmitting signals from a variety of stimuli inside a cell into its interior, the most common method of signaling to cells. This artificially blocks cells from receiving the compounds that signal pain. Morphine causes slowed reaction time, possibility for seizures, depressed consciousness, and general psychomotor impairment.
Are you filming this right now?
Mm-hmm.
Pharmacist assisted the time. Oh no, I messed it up.
Go back to the vlog.
We are vlogging. Oh no.
Get your together, Stu. Thank you for watching.
Thank you.